Okay, today we start section 9.2. 9.2 is all about a specific type of sequences called arithmetic sequences. Okay, I mean, we've got sequences of all kinds. This Venn diagram might help you kind of understand the big picture, include it if you want to in your notes. But we've got something called arithmetic sequences. And then in section 9.3, we're going to talk about geometric sequences. And then we also have recursive sequences we could put in here. And then some that might not be arithmetic or geometric. But arithmetic sequences just simply have a common difference. Okay, so we're going to work on recognizing that, writing, and finding in terms of arithmetic sequences today. I'm not sure if we'll get to partial sums. All right, so the common difference is that number being added from A1 to get to A2. All right, so this should be common. If I subtract those terms, it should be the same if I subtract A3 from A2, and so on. That's what they're trying to show you. It equals some common number. That's how you know it's arithmetic. All right, so determine whether the sequence is arithmetic. If so, find the common difference. Okay, so you start checking for that. You take the 7, you subtract the 2. You take 12, you subtract the 7. Is that a common difference? Absolutely. Okay, so here I started it here. I put A2 minus A1 is 5. Right, A3 minus A2 is also 5. My 3-hole punch kind of took that part out, but that's what I was showing. All right, the 12 minus 7 equals 5 again. Okay, so we say it's arithmetic, and it did say give the common difference. We use the variable D for common difference. Okay, let's look at number 2. Is there a common difference? Start doing the math. What's 27 minus 81? Negative 54. Is that common? 9 minus 27. That's not common. Okay, so the answer here is no, this is not an arithmetic sequence. It might be a sequence. There's a pattern. This one actually happens to be geometric because there's something being multiplied, but that's for next section. Okay. All right, let's see. Go ahead and take a look at 3 and 4 and try to make the decision on those, and then we'll do those together. All right, with these denominators not common, it's kind of tough to tell. So if I take 2/3 and make it 4/6, take 5/3, double the top and bottom, get 10/6, it's a lot easier to tell that there actually is a common difference. What's being added? Negative 3/6. The denominator is going down, or negative 1/2. Okay, don't forget the sign, because if it was positive, then this would be going up, right? This was a positive common difference up here because it was increasing. If it's decreasing in value, we need to make sure we have the negative. Okay, so yes, arithmetic, D equals negative 1/2. Here's 4. This was a little bit easier to spot. Yes, D equals negative 4. All right, so now we got that definition down. This is really an extension of 9.1, but now we're adding this new concept to it. Write out the first 5 terms of the sequence. We've seen that before. We know how to do that. Once you get the sequence in front of you, we're going to determine whether it's arithmetic. Okay, like we did up there. If so, find the common difference. Okay, so kind of a hybrid problem. So for number 5, I'll walk you through this and let you try one. How do we find the first term? Like we did in section 9.1. Throw it into the formula. We get 76. Throw in 2. So now I've got 4 times 2, which is 8. Take it away from 80, 72. Okay, if you don't want to show the work problem, you don't have to because we're just subtracting. And then after you get about 3 of them going, you probably see the pattern. Looks like it is going down 4. So here's the first 5 terms. Yes, it is arithmetic. Okay. All right. So we're going to pause here and let you try 6 and 8. So once you skip 7 for now, try 6 and 8, and then I'll give you feedback. Okay, number 6. Here's your first 5 terms: 3, 18, 81, 324, and 1215. Definitely the gap is increasing, right? From 15 to a big number. It's clearly not arithmetic. No common difference to report. 8, however, does have a common difference. Here's the sequence. If you wanted to write the 5 terms this way instead of labeling them, that's fine. There they are. There's a common difference of positive 3. Okay, let's look at the next page. All right, this is a formula that we will use. This will be given to you on the quiz and test. You just have to know how to use it, when to use it. All right, this is just a handy way to, if you want to find the 6th term or 7th term, it's pretty easy to do without a formula. But if you want the 150th term or something like that, this is going to be needed. Okay, so in order to write a formula, just make sure we know what you need. You need the first term, or A1, and the common difference, and D, to write the formula. So 2 things that are needed. A1 and the common difference to write the formula. Okay. You keep N the variable because that's what you plug in. If you want to find the 100th term or 25th term, you plug it in there. So N stays as a variable. Okay, so find the formula for a sub n of the arithmetic sequence. So here we go. We're going to use this right here. I'll just make sure you're very clear on what we're using. So I'm just going to rewrite it here. We could put the common difference in front of this quantity or after it. For whatever reason, they put it after. I'll just follow suit with that. Okay, so let's plug in 3 here, and the common difference is going here. So we have a sub n equals 3 plus n minus 1 times a negative 7. All right, now we don't usually leave it in this form. If you check it in the back, they're going to have it simplified, so I want you to do that too. So I'll make note here to simplify this. So that would just involve distributing the negative 7, multiply the negative 7 through this quantity. So that gives me 3, and then I've got a negative 7n or minus 7n, and then negative 7 times negative 1 is positive 7. All right, and then the 3 and the 7 obviously are like terms. So my formula is going to be negative 7n plus 10, unless you wrote the 10 first. 10 minus 7n would work as well. Okay, so that's the formula that now we can use to find any term quickly. Okay, any term quickly. Throw in the n back. Just like we did in section 9.1, right? A sub n formulas. Okay, you try it for 10. Pause and give it a shot. All right, here's your feedback on 10. Distribute the 1/4. We get this. And then negative 12 minus 1/4 is, just make it a mixed number is the easiest way to do it. Or negative 12 1/4, 0.25. Okay, this next example is a little more difficult because they don't give us D. So we have to figure out the D, the common difference right away. Okay, so the direction is still the same. We're still trying to find a formula for the a sub n sequence. We must find the common difference though. All right, so, some of you guys have good mathematical minds. You can realize that, hey, I just need to subtract that to find the difference and divide by the missing terms of 4, because there's 4 terms to get there. But some of you don't see that, so let me try to give you a little better path or more concrete method. We must add the common difference four times to get to a sub 5. Okay, write that down, then I'll explain in a little more detail. We must add the common difference 4 times to get to a sub 5 from a sub 1. Okay, how am I getting that? Well, let me just use this example from 8 as an example. This had 5 terms. This is A1 and this is A5. So how do I go from A1 to A5? Well, I add 3 once, twice, 3 times, 4 times. Okay, so what's the shortcut? 5, a sub 5, a sub 1. Just those n values. 5 minus 1 is 4. That's how we'll get the number of times we have to add the common difference. So it was A1 to A6. I do 6 minus 1. 5 times we add the common difference. Okay, so just make sure we're clear how we got that 4 times. It's basically the 5 minus 1, the fifth term minus the first term. Okay. All right, so here's a little formula I could create to do this. I'm going to start at A1, 24. So A1 plus 4 common differences to get A5. There's other ways you could do this. I'm just trying to give you a concrete path in case you like that. So I've got A1. I add the common difference 4 times to get to 52. A5. All right, so it's just throwing what we have. 24 is A1. 52 is A5. Okay. And then I got to solve this for D. So subtract 24. Okay. And this is where some of you, like I said, have a good arithmetic mind. And that's kind of what you do anyways. You say, all right, I'm going to find the difference of these, which is what this formula is doing for me right now. This equation is. It's 28. And then how many times did I have to add the common difference? 4 times. So I'm going to divide that difference by 4. Okay. So I get the common difference is 7. That's what makes this problem a little bit tougher. Now that we have the common difference, just like numbers 9 and 10, but that's the work ahead of time. Okay, so back to the formula. This one up here. A sub m equals A1, 24 plus n minus 1 times the common difference, which we now know is 7. You can always check your answer too, right? If it's 7, just make sure you start adding 7, the correct amount of times to get to 52. All right, and let's simplify this. (24) take away 7 is 17, so we got a sub n, 7n plus 17. All right, your turn. Try number 12. Okay, now if there's one on your quiz, it'd be more like 11. 12 is a little more advanced because there's another additional step on this one, so let me take you through this. All right, so how many times do we have to add a common difference to go from A6 to A12? Remember, subtract these numbers. 12 minus 6 is 6. So basically to go from A6 to A12, this is what we do. A6 plus 6 common differences equals A12. That's going to kind of get us going. Okay, unless you just know how to subtract it and divide by 6, that makes sense to you, fine. That's basically what we're doing. 15 minus the negative 9 gives me 24. And then I divided that by the 6 places. Common difference of 4. Now, I saw a lot of you get common difference of 4. That's good. But remember, when you create this formula now, you have to start with A1. We don't have A1 yet. And a lot of you guys just took that and threw that in for A1. So now that I have a common difference of 4, though, can't you just, go backwards 4? You could to get to A1, manually do it. But they're still 5 spots away. So this is kind of what I did to write it down. So to get A1, I've got to start at A6 and subtract 5 common differences. Okay? So you could do it every step along the way if you wanted to, or you could do it all at once like I did and just did it this way. Did it 5 times. Okay? So negative 29 is A1. Now I can write the formula. Like I said, this is a little more advanced. Don't get too stressed out. You're stuck on it. Number 11 is something you got to focus on a little more. So now I've got A1 plus n minus 1 times the common difference of 4. Distribute the 4. And then we get this for the answer. Okay. All right. 13 just says write the first 5 terms of the arithmetic sequence. If they give you the first term and the common difference, and you know the definition of it, all you have to do is start adding it. Add negative 5. That's it. That's how we get the sequence going. Okay? We're going to skip 14 for now. We're going to end there for today.